G'day folks, my name is Ben Rolfe and my pronouns are he and him. Today I'm coming to you from Gubby Gubby country, which you may also know as the Sunshine Coast of Queensland. Today's tutorial is an intro to Unity for audio people. Now, most beginners tutorials leave out audio entirely, and that's not because audio is an advanced topic at all. They just leave it out to make room for other things. But for the Audio Game Jam 2020, for obvious reasons, we wanted to kind of flip that script and really focus in on getting you up and running in the game engine and making some sounds, right? So today you're going to learn how to bring audio files into the game engine and play those sounds, how to play a sound in response to a player action, how to move sounds spatially around within the scene, and some very basic audio manipulation. Now this isn't a programming tutorial, but we will be doing a little bit of code today. If you've done some code before, that'll certainly help, but it won't be required. You can kind of get away with just copy pasting and that'll do for now. Now, I'm not really an audio person myself. I'm more of a generalist programmer, so apologies in advance for basically every aspect of the quality of the audio files I'll be using today. So without further ado, I'll head inside and let's get started. Okay, so here we are in Unity Hub, and the first thing you're going to want to do is to create a new project, which you do just by clicking on New up here. Now there'll be a few different options. For today we're just going to use the 3D project template. It doesn't particularly matter which one you use, even if you were to choose 2D and then later decide that you're doing a 3D project. There's only a few things that you actually need to change to sort of swap from it being a 2D to a 3D kind of project. So if you're not kind of sure exactly what kind of game you're wanting to make, don't stress out too much about this initial decision. So over here we need to give it a project name. I'm going to call mine AGJam tutorial. And specify a location if you need to. I just put all of my projects under a repos folder inside my documents folder. So yeah, then when you've done those things, click on create. Cool. So here we are inside Unity. And this is what an empty project looks like when you first open it up. If your layout looks sort of a lot different to this, it's possible that you're in a different layout. There are different layout options up here in the top right. I generally work in 2x3, but for this tutorial we're just going to be working in the default layout. So the first thing we need to do, I guess, is to familiarize ourselves a bit with the Unity interface and what all the different parts are. So starting up here in the top left, this is called the hierarchy, and it's really just like a list of all the different things that are in the scene. And at the moment we're looking at a scene called Sample Scene, which has a main camera and a directional light in it. Over here, just to the right of that hierarchy, we see the scene view. And those two objects, the camera and the light, we can see within this scene. So I'd like you to spend just a minute or two getting a bit used to navigating around this 3D scene, because you're going to need to do a bit of that as you make your game. In order to kind of start with that, let's add something a bit more visible into the scene so that we can kind of move around it. And what we're going to do is we're going to add a cube. Now, when you're adding anything into a Unity scene, there's a couple of different ways to go about it. One of them is you can add it through this Game Object menu up here. The other way that I normally use is just this plus button above the hierarchy list here. So let's click on that plus button. Let's go down to 3D Object and say we want a cube. And that will put a cube just in the middle of the scene here, and you'll get these big arrow widgets coming off that cube. And we'll deal with them in a minute. We'll look at how to sort of move and manipulate objects within a scene. But for now, we just kind of want to move around within that scene. And I'm going to show you kind of how to do that. So the first thing we can do is, using the scroll wheel on our mouse, is we can zoom in and zoom out. We can, holding down the right mouse button, you'll see that the icon there changes to an eye and a little representation of the WASD keys. And with the right mouse button held down, we can look around the scene. left and right, up and down. And using those WASD keys, we can also kind of fly around, flying in and out using W and S, and left and right using A and D. And that's really kind of cool. That's how we generally will be navigating around a scene. Sometimes we can kind of all get a bit kind of messed up and lost and not know where our objects or our entire game is, and that can get a bit alarming and frightening the first time you use Unity. It's like, am I ever going to get my game back? Yes, you are. The easiest way to kind of get back to where you were is to find one of your objects over here in your hierarchy and just double click on it. So I'm just going to double click on the cube, and that will center my view back on that cube. Now I'm still upside down. The sky is still below the ground here. We can just kind of fly around a bit and try and get it up the right way, which will work. But another way to go about that is using this little sort of compass widget on the side here. If we click on any of the different axes on this little widget, and I should show you this widget moving around as I pan and rotate. If you click on any of the axes, then we get a view directly down this axis. And so if you click on either the Z or the X axis, you'll get a sort of a view that's the right way up and just looking directly down that axis. And if you should happen to want a top-down view, you can click on the Y axis and get a view from the top here. And we can see our cube sort of through where our directional light is here. So yeah, take a few minutes. Oh, wait, sorry, there's one more control I should talk about. If you hold down the middle mouse button, or if you hold down the mouse wheel, your icon turns into a hand here, and we can kind of drag that back and forth, just sort of drag the scene around. So right mouse button for looking around and rotating and flying, and middle mouse button for dragging our scene. And a combination of those things lets you sort of navigate around the scene. If you don't have a mouse wheel that you can click down, then you can actually come up here to the top left and just select the hand tool, and then just using the left mouse button will drag the scene around exactly as holding the mouse wheel down does. So yeah, just spend a few minutes kind of just flying around this cube for a while, getting in and out, because you're going to be doing this a lot, and it sort of is often for people who haven't kind of worked in a 3D environment before, can be a bit frustrating. So just take a little while to familiarize yourself with that. Okay, so once you're familiar with moving around that environment a little, let's get into actually manipulating objects a bit. We're going to use these buttons, these controls up here, to move, rotate and scale our objects. The control that's currently selected is the Move tool, and that's the one that I normally just have selected all the time when I'm just working within a Unity scene. And while that Move tool is selected, you can just click on any of these arrows and drag the object along those axes. So if I click on this blue arrow here, I'm dragging it along the Z-axis. If I click on the red arrow here, I'm dragging it along the X-axis. And if I click on the green arrow, I'm dragging it along the Y-axis. I should talk a little bit about the axes that Unity uses. The X-axis is left and right. So if I come back here, sort of looking at this scene from the same position as the camera, yeah, the red arrow is the X-axis, and that's right and left. The Unity is what's called a Y-up orientation. So the Y-axis in Unity is up and down. In other bits of software, you'll often find that the Z-axis is up and down. But in Unity, the Z-axis is forward and backwards, or in and out. Now it can be easy, a bit like sort of getting yourself lost. It can be easy to kind of lose your cube off into space sometimes, and then like click off it and it's sort of way off in the distance there. If we want to bring any object back to the sort of center of our scene, if we just select it here in the hierarchy, let's come over here and look at the inspector. So the inspector tells us information about the object that we currently have selected. We'll talk about the rest of this stuff down here shortly, but for the moment I just want to focus on this transform area, and this is called the transform component. Every object in Unity has a transform component, and that tells us the position of the object, its rotation in space, and its scale, how large it is along each of those axes. And you can see here that at the moment our cube is at negative 0.19x, so it's a little bit to the left. Units in Unity are sort of nominally meters, so this is like 0.19 meters to the left, 0.45 meters up, and it's 248.4 meters forward, so that's why it's way off in the distance there. If we want to bring it back to the center of our scene, we just come here and we say 0, 0, 0. And that 0 is our cube back at the origin of our scene. Okay, so the other thing with the move tool, I should have mentioned that to select an object, you can either click on it in the hierarchy here, or you can click on it in the scene view. Both of those are the same thing. So in addition to clicking on those arrows, you can also click on these planes. And the planes are kind of the opposite of the arrow of the same colour. So this blue arrow here and this blue plane here, this blue arrow will move the cube just along the z-axis. This blue plane will move the cube on both of the other axes. It'll move it along the x and the y-axis, but it'll keep it fixed on the z-axis. So we can click it there, and that kind of rotates it around, but it never goes in and out. And if you look over here in our transform, you can see that happening as I drag it around. You can see that the x and the y values are staying the same, but the z value is remaining fixed. Similarly, the green arrow means that we move it just on the y-axis. The green plane means that we don't move it on the y-axis at all. We just move it on the x and z. Okay, let's move that back to 0, 0, 0 again. So the second tool is the rotate tool, and we can click on that here. The shortcuts for each of these tools, tool buttons, are the QWERTY keys. So Q will jump you to the hand tool, W to the move tool, E to the rotate tool, and so on. Or you can just click on them, obviously. So this is the rotate tool. Our arrows have gone, and we've got these kind of circles in a sphere here instead. And these circles let us obviously rotate the object. So I can rotate this object around the x-axis. So the x-axis is left and right, and rotating it around the x-axis is like nodding your head, I guess, or a motorbike handle. So it rotates it in that direction. And you can see after each sort of rotation, it snaps those circles back to where they were. If you're not getting that happening, just make sure that you are using, that you've got these things set as pivot and global. Because you see, if I'm using local here instead of global, those circles are oriented to the local coordinates of that object. And if I come back to the move tool here, you'll also see that those arrows, instead of being aligned along the global X, Y, and Z axis, are kind of aligned along the X, Y, and Z axis of that rotated object. If that doesn't quite sink into your head right now, that's okay. Just make sure that these are in pivot and global, and those are the settings that you're most often going to want to use. I've kind of got our position and rotation all messed up at the moment. I'm just going to bring these back again to 0, 0, 0 to center it in the space, and I'm going to set the rotation to 0, 0, 0 as well to bring it back to the default or neutral rotation. So yeah, back to the rotate tool. Using these red, green and blue circles, we can rotate the object around in each of those axes. The white circle I generally don't use. That actually rotates the object according to the direction that we're currently looking at it. So if I rotate it now, it'll sort of rotate it around just along that sort of forward axis that the camera is currently looking in. I generally don't find that useful at all. So yeah, kind of set this back to 0, 0, 0. Also, if we hold down Control when we rotate, we'll move in 15-degree increments. And that can be really handy if you're sort of wanting to rotate something just by 45 degrees or 90 degrees kind of thing. I should also point out that kind of works with the Move tool at all. If you've got Control held down, it'll drag it in increments of 25 centimeters. So yeah, that can be super useful. Just zeroing these out again. And yeah, finally the Scale tool here. Again, our widget's changed to these 3 coloured boxes and a white box. These let us scale the object in each of the 3 dimensions. So we can make it longer, and let's make it a little bit flat. Got a kind of a plank, or we might want a sort of a floor. But now let's come back to a plank. So yeah, these settings will scale the object in each of the 3 dimensions, and the central white box will scale it in all 3 at once. So it keeps the proportions the same and just scales it up or down. Now, if you've messed that up and you're kind of wanting that to set it back to normal, you don't want to say scale of 0, 0, 0, because that'll scale the object right down to being a minuscule point. So it's kind of nothing. In fact, if I click off it, we can't see the box at all. I'll select it again from the hierarchy. So to scale it back to normal, instead of scaling it to 0, 0, 0, we scale it to 1, 1, 1. So those are sort of the 3 basic operations. You might find that you're most comfortable clicking and dragging things around here. You might find that you're a more sort of numeric sort of person, and you prefer just setting them over here, and either of those is fine. I'm not going to explain these 2 tools here. I will just click on this one here. This is sort of a multi-tool that lets you move, rotate, or scale. So it's got all three of those things that I was talking about. We can move, we can rotate, or we can scale. It doesn't let you scale on the 3 different axes. It just lets you scale the entire object. Generally speaking, I don't use that one at all. It's just got too much going on for me. I generally just use those each of the tools individually. Okay, so setting back that back to 0, 0, 0, 1, 1, 1. I'm going to come back to the Move tool here. Okay, now, as I said, let's talk a little bit more about these values in the inspector. We've had a good look at what the transform component is, and I just want to talk about components in general, I suppose. If we look at the cube object which we created, that cube object, if I just collapse each of these components, we can see that the cube object has a transform component, a cube component, a mesh renderer, a cube filter rather, a mesh renderer, and a box collider, and it's also got this material attached. If we look at the main camera, and again I'll just collapse these, we can see it's got a transform. Like I said, every object has a transform, and it's got a camera component and an audio listener component, and we'll talk a little bit more about that audio listener later, obviously. I just want to point out that the only difference between these 2 objects is the components that are attached to them. I can come over here and I can create an empty component, right? And that's just a nothing floating in space. It's a point in space. It's got a transform, which means it has a position, a rotation, and a scale, but it's got nothing else on it. if I want to turn that into a camera, I can. I can just say, all right, what was on our camera? A camera component and an audio listener. I can come to our game object and I can add a camera and I can add an audio listener. If I can type it, I can add an audio listener. And you'll see there that it's got our little camera picture now. And there's now really nothing different between these two objects. They're both camera objects now. That operate in the same way. So there's nothing special at all about base objects in Unity. What makes objects the things that they are the components that are attached to it. Now, I don't want two cameras in my scene, so I'm just going to delete that now that I've shown you that that's how components work. Okay, now I did promise that we're going to jump straight into audio, so there's just two very quick things that I want to show you in addition before we get stuck into that. One of them is play mode. So currently we're in edit mode. We've just been editing our scene. If we want to actually play our game, to sort of test it out, we can just use this play button up here. So I'm going to click on that. I'll talk in a second about why everything just went green. And so now we're in play mode. You'll see here that this we're now on the game tab. We were on the scene tab before. And the view that we're getting at the moment is looking through that camera, and we're looking at the cube. We can come over here to scene and we can still edit things just as we did before. But a word of warning, something that often traps people who are new to Unity and sometimes even who aren't that new to Unity, I know I've been caught out with this myself several times, is that these changes that I've just made to that cube while in play mode are temporary. As soon as I press this again to leave play mode, those changes will be erased. And I have at times worked for over an hour without realizing I've been in play mode, and then hit that and it's all vanished, and there's nothing you can do to get that back, and it's very, very sad. So one thing that you might want to do to make sure that it's really clear where you're in play mode or not is to change the tint of your window. And like I said, I've changed my tint here to green so that when I hit that play button, it's really obvious that I'm currently in play mode. So to change that tint for yourself, you can come up here to Edit, Preferences, and you want to come over here in the left-hand column to Colors, and this Play Mode Tint under General, should be the fourth one down, is what you want to change. And you can change that to whatever colour you want. Now, the final thing I want to show you is this section down here. This is the project, which is basically, it's a list of all of the folders and files that are in your game. These are sort of assets that you can bring into the scene. Until you do, they're just kind of sitting there as a file, and in fact, if you don't use them at all, they won't even be put into the build. Now, I'll provide a link below to a zip of the sound files that I've used in this tutorial, or you can use your own sounds if you like. Generally speaking, a lossless format like WAV is the best for importing your sounds. That said, we're working in a kind of distributed game jam here, and if you want to just keep file sizes small, then using a good compression format like OGG is another perfectly reasonable way to go. Try to avoid MP3s, particularly if you're using looping sounds, because the compression at either end doesn't really let them loop properly. Okay, so first of all, let's create a folder down here in our assets to store our sounds in. So I'm just going to create folder, and I'm going to call that audio. Then find your sounds, select them, and simply click and drag them onto your audio folder. And that's all. Unity has now imported each of those sounds. Now, there's potentially a lot more to it than that. You can change the settings on how these sounds were imported. and really, yeah, there's that depends on what you're using the sounds for. Like, is it going to be ambient background, or is it going to be something that happens in response to the player kind of collecting a pickup? Those, you've sort of got different settings that you're going to want to use in each of those cases. What I'm going to do, that's sort of beyond the scope of this tutorial, and it's also something that I'm going to defer to the expertise of others on. I'll put a link to Xander Holmes' tutorial on importing sounds into Unity for that one. So if you're interested in sort of the best way to kind of have this set up, then check that out. That said, it's a game jam, right? Probably whatever you have by default is going to be fine for now. So let's get one of these sounds playing. Now, in Unity, each sound comes from an audio source, and each audio source needs to be attached to an object. So what I'm going to do is I'm going to create an audio source on the cube that is playing our bum bum sound here. And to do that, all I need to do is just drag this from our assets onto the object that I want to be playing that sound. So I'll just drag it onto that cube there. Now if I click on the cube, you'll see that in addition to these components that were on it before, Unity's added an audio source, and it's set the audio clip for that audio source to be the bum bum sound. If I decide, oh actually, oops, I meant to put the R sound on there, I can just drag that R sound into there as well. I can also, if I want, just another way to do that is to click on this funny looking little circle here next to the audio clip that's currently on there. And this will give me a list of all of the audio clips that are in my game. It can get a bit unwieldy if there's just like loads and loads of different audio clips, but for this amount it's sort of fine. Let's come back to Bum Bum. Alright, so you can't currently hear that playing. If we want to hear a sound playing, then we need to go into play mode. So I'm just going to hit that play button and you'll hear my dulcet tones. Lovely, isn't it? Okay, enough of that. I'm actually going to hit play again. It's just hard to hear me talking over hearing me singing, in quotes. So let's, in play mode, hit play and have a play around with some of these settings here. Ignore priority for now. Try it with loop and without loop, and obviously you'll see that the sound will end if we don't have loop ticked. Volume's pretty obvious. Pitch is interesting. Let's give a few of them a go. Yeah, let's start by turning me down. There we go. So that quiets me down a bit. Pitch, we don't have it looping. Let me stop it. So you'll see again, as I said, those changes I made while we were in play mode, as soon as we came out of play mode, they disappeared. If I make a change now, like turning loop on and changing the volume, those are permanent changes. So here we go. So yeah, these have changed. If I hit stop again, they're still what they were. Okay, so pitch will change the pitch. It'll also change the speed. That's the way that Unity changes pitch in a very simplistic sort of way. So you can get a bit of Alpha and the Chipmunks going on. We can pan it from the left to the right. So from -1 to 1 or 0. And I'm just going to stop that and talk a little bit about spatial blend. So you saw me panning the sound there from the left to the right speaker. That's what's called 2D blending in Unity. 3D blending is where the game engine actually takes into account where that object is, the object with the audio source on it, relative to the object with the audio listener on it. I should mention you can only have one of these audio listeners active in the scene at a time, otherwise Unity will complain to you. So let's have a go at using 3D rather than a 2D spatial blend. You can also in Unity like have a blend part way between those two different blend modes. I haven't found a particularly good use for that. Maybe you will as part of your game jam experience. For me, I sort of I question why that's there, I suppose, but there's probably perfectly good reasons. But yeah, for now, let's give it a go in 3D blend mode and hit play. First thing you'll notice is that it's quieter, and the reason for that is that we're now hearing it from a distance. I'm going to turn this up a little bit. So yeah, we're hearing it from that cube in the distance. If I come back to the scene view so I can drag things around, I should have mentioned before you can't move things in the game view. So I come back to the scene view here, select our move tool, and remember our listener is here on the camera. So if I drag our cube, well, let's drag our cube a bit closer and to the camera. It gets louder. Drag it further away, it gets quieter. You'll hear there that as I move it like towards or away from the camera, we actually get a bit of a Doppler effect as well, where the pitch increases as we're approaching the listener. If you're doing it quickly enough, then you'll notice. We can drag this again off to the right and we hear it from the right. So that's just a really nice, simple way to get basic 3D audio spatialization happening. It's not doing anything too fancy. I mean, it's doing a Doppler effect, which is kind of nice. But yeah, if you're wanting sort of more advanced kind of spatialization of sounds, particularly if you're wanting anything like echoes or even occlusion, where a sound on the opposite side of a wall is quieter, then unfortunately you're going to need to go to a plugin for something like that. That's sort of not a capability that's built into the kind of the basic out-of-the-box Unity. So that's all well and good if we've just got a audio source that's just playing the same sound on loop, right? But most of the time, what we're wanting to do with audio is going to be a little bit more interesting than that, right? So I'm going to talk about a couple of different things that you can use to make slightly more complex and interesting solutions with sounds in Unity. First thing I'm going to talk about is called timeline, which is a visual sequencer for both animation and audio. And the second thing I'm going to do is show you some really basic scripts that you can use to trigger sounds. Before I forget, now might be a really good time to save your file. Control S should do that. You can also come up here and go File. You can save, will save the scene, save project will save the entire project. I generally just go save project just to kind of be on the safe side, I guess. Okay, so let's take a look at timeline first. So to open up timeline, before we open up timeline, let's remove this audio clip from here. We can leave it playing, and timeline will kind of play things on top of or in addition to that audio clip. But let's just click on that little circle and select none. And so now that's an audio source, but it's not playing any audio clip. And we're just going to use timeline to control the audio clips that audio source is playing. So I'm going to select our cube, because this is the thing that I want to attach this timeline to, and come up to Window, Sequencing, Timeline, and click on that. Now at the moment, it's sort of added a tab here, a timeline tab to this central view, and we can go back to scene if we want, or come to timeline. And currently there's not a timeline attached to that cube, and this is telling us that to begin a new timeline with cube, create a director component and a timeline asset. We don't sort of need to do those things because clicking the create button will do it all for us. So we click on create. It wants to know what this timeline asset is called and where we save it to. I'm going to save it. It needs to be saved inside your assets folder. I'm going to create a new folder in here called timelines, because we might have several different timelines operating on different objects. And it's decided to call it cube timeline. I'm happy with that. Let's just go into that folder and click on save. Okay, so now we have a cube timeline, and if we scroll down here, we'll see that two new components have been added to our cube, a playable director and an animator, each with their own different sort of values. We don't need to touch any of this. Everything that we're doing is going to be within this timeline window here. So we were playing the bum 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 sound before. So let's bring that one back in, and we can just click on the sound down in our assets here and drag it up to our timeline. Now, yeah, currently we have an animator on the cube. That will let us do things. In fact, in a minute I'll show you how to make that spin the cube around. But each time we add a new sound on here, it'll add a new audio channel, or we can add it into an existing audio channel. So we've got this bum bum sound. I'll just drag that to the 0 point, and it'll snap there nicely. I've sort of set up most of the sounds in here to be of nice, easy lengths to just make this process a bit easier. You can zoom in and out of this timeline with the mouse wheel. If you hold down Control, it will zoom just vertically like that. And then you've got this this bar here. Oh, sorry, to move back and forth with. Okay, so let's just say that we want to have that bum 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 sound, and I also want to put some of these clicks on top of it. So I'm going to, let me zoom in a little bit more. Okay, so got these 3 clicks. And I'm going to do that with it, and we'll see how we go. So I imagine that this is probably familiar to most people who sort of worked with audio, this kind of idea of a visual sequencer. So I'm not kind of really explaining what that does. Our playhead's going to move from left to right and play those sounds along the way. I hope that's sort of a familiar and understood paradigm. Now, notice that if we come back to scene and try and play with the volume, nothing's going to happen. And the reason for that, that loop just ended, the reason for that is that we're not currently playing the sound through that audio source at all. If I come back to here, to the timeline, you'll see that for each of these 2 tracks, no audio source has been selected. So it's just kind of playing those clips just kind of globally. They're not going through an audio source, so they're not really being listened to by that audio listener, and they're not oriented anywhere in space for this spatial blend to happen. So let's let Unity know that we want those tracks to be played through our cube's audio listener. We do that just by clicking on this odd little circle again. I think it's a target. I think it's targeting the specific objects. And so we want to play those sounds out of the audio source that's attached to our cube object. So if we give that a play again, we should be able to mess around with the volume here a bit. And also if we drag the cube around, that will spatially position the sound. But notice still that even though we have loop selected, that the sound isn't looping. And in order to fix that up, we need to make sure that the timeline is looping. So not this clip, that's this sort of loop means that it will loop that audio clip. We need to loop the timeline. And in order to do that, we need to come down to the director component, the playable director component that is on our cube object. So make sure if it's sort of no longer selected, make sure that your cube object is selected. Come down and find the playable director, and under wrap mode here you'll see that it's currently not wrapping, and we need to make sure that that is looping. Let's give that a play now and just make sure that it's working. Okay, now that's looping around. One thing that I've realised is that this is playing much more quietly for you than it is for me. So I might just fix my levels up a little bit. Okay, so I sort of mentioned earlier that in addition to using timeline as an audio sequencer, we can also use it as an animation sequencer. And what I want to do is just create a really very simple animation just of that cube rotating around and round and round. And you'll see here that there's already this channel here that has the cube animator on it. And you'll see here it's got a little red circle, which is actually a record button. When I click the red circle, we'll go into record mode, and then any changes that I make to that cube, and I'm going to be changing the rotation of that cube, will be changed on the frame that we're on. So I'm going to say, well, let's add another bum 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 here. I'm going to say that after 2 complete bum bum bums, I want the cube to have rotated. Well, let's say it's gonna. This is after 2 complete bum bum bums. We'll be on frame 960, and that's a nice. What is that? Okay, totally didn't just pause the video to do some maths. That's not what just happened. I just needed to get a drink of water. That's it, yes. Okay, so now that I obviously know that that 4 times 360 is 1440, and just, did that off the top of my head like that, we are going to say that after these 960 frames here, we want to have rotated that cube around by 1440 degrees. So over the time that it takes to do 2 of these full loops, we're going to rotate the cube 4 times. So let's make sure we've got our cube selected, hit the record button, make sure that we're on the final frame here, that frame 960. If you're having trouble like landing on exactly the right frame, just zoom on in a bit and you'll be able to be a bit more precise with selecting. Again, I just zoomed by using the mouse scroll wheel. So I'm on frame 960 here, and I want to set at that frame the Y rotation to be 1440. And you'll see here that these cells have gone red or pink, I guess, to indicate that their values have changed. So even though not every value has changed here, it's sort of detected that there has been some position and rotation changes, and so it's made those changes there. So at position 960, our cube has rotated 1440 degrees. But if I scroll back a bit, you'll see that that value hasn't changed. So I've actually changed that from the very beginning of the timeline. So let's come back to the very beginning at point 0, and let's change that Y value to 0. So it goes from 0 rotation to 1440 rotation across that. And if I just scrub across the timeline here, you can see that that Y value is changing across those frames. And it's worked out that 1440 is actually the same as 0, and so it's actually kind of giving us these sort of values between 180 and negative 180, which is fine. That in terms of rotation, those all mean the same things. But by starting out with 1440 there, we got Unity to work out those sort of tweening values for us. So I'm going to hit the stop recording button now, and it's still got those kind of checkpoints there. Let's give it a run and make sure that it's actually working as we're wanting it to. So yeah, the cube's turning. If you pay attention here, you'll see that it's kind of speeding up. So it starts off quite slow, speeds up, and then slows down again. To make that really extra obvious, what I'm going to do is attach another object to this cube. So if I come back to the scene view here, what I'm going to do is come down and I'm going to create another 3D object. This time let's create a sphere. Now, often when you create objects in Unity, I believe that it creates it at the sort of point that the camera is currently looking at, which generally isn't the origin. So it's kind of created that sphere in a bit of an arbitrary spot down there. Let's just quickly come here and zero it into our origin again. And then let's drag it out here a bit. Let's bring it out, say 5 meters along that z-axis. And at the moment, the cube and the sphere are totally separate objects. But if we click that sphere and drag it into the cube, then now the sphere is like a child object of that cube. If I move the cube around, the sphere comes with it because the sphere is sort of contained in the cube. If I, not quite sure why I got a rotation there. If I rotate that cube around, it rotates the sphere with it. And that's what we're wanting, just to see the rotation animation a little bit more clearly. So let's give that a play. So yeah, now we can see a bit more clearly that that animation is speeding up as it gets to the middle of those 4 rotations, and then as it gets to the end, the rotation's slowing right down again. And in this case, that's not what we want. We often do want that with animation. We want it sort of to ease in and ease out, and that's why it's kind of set as the default. In this case, we don't. We want it just to be a linear rotation. So let's come here, back to Timeline tab, select the cube, and you'll notice that next to the record button, there's this little graph icon. And if we click on that, then we'll see the curves. And you can see here that that yellow line, which represents the Y rotation, and let me just open that up. There we go. So you'll see that there's a pink line representing the X rotation, a yellow line representing the Y rotation, and a cyan line representing the Z rotation. So we don't want this to kind of do that nice curve of sort of slowly easing in, then speeding up, and then slowing down again. We just want this to be a straight line. And to do that, we just need to right-click on each of these endpoints and come down to both tangents, linear. You could also go left and right tangent, but it's just a bit more straightforward to go both tangents. Both tangents, linear. And now we see that animation, that rotation, is a nice straight line. Let's close that graph again, just by clicking on the graph icon. Give it a play just to make sure that it is actually behaving as we expect. We saw there that straight off it's sort of rotating at full speed. It's not sort of speeding up and slowing down, it's just keeping rotating round and round and round, which is what we want. So now what I'd like to do, just so that we can properly appreciate sounds moving in space, is attach some sound to that sphere as it rotates around. So let's, well, for one thing, let's bring the camera in a little bit closer. At the moment it's 10 meters back. Let's just change that -10 to a -5. So this is now 5 meters back from the cube and 1 meter up in the air. Let's also change that cube just bring it in a little closer so it's 4 meters. The reason that I've done that is just that I want us to be able to see this cube kind of zipping in close to the camera. Sorry, the sphere zipping in close to the camera and then going further away. So that when we put a sound source on that sphere, we kind of can hear it really moving around in the space. So let's select the sphere. Now, I could do what I did before and just drag one of these sounds onto the sphere. I just want to show you an alternative way to add an audio source to an object. And that's just to make sure the object that you want to add the audio source to is selected. Then come over here to the inspector, and right down the very bottom of the inspector you'll find the Add Component button. And we're going to go Add Component, and there's a whole lot of components you can add, right? Like there's all of these different kind of folders that are all full of things. Generally when you add a component, the thing that you want to do is just start typing the name of that component. So we're just going to type audios, and it goes, yes, here you go. You want an audio source. And we say, yes, we do indeed. And so that's created an audio source for us. It doesn't have any audio clip on it, and that's just fine, because we are going to use that same timeline that's attached to the cube to play a sound on the sphere as well as playing one on the cube. So let's come back to the timeline tab, make sure that our cube object is selected, and now we're going to drag our aha sound onto another track. Just going to make sure it's lined up. Obviously I've kind of created sounds that are nice and easy to line up with each other, which helps a lot. In some cases you might need to be a bit more fiddly with it. Now at the moment this sound is not playing through any audio source. Let's select our audio source here, and you'll see now that the sphere has an audio source on it. It's in our list. So I say I want to play a sound on that sphere, this RR sound. I'm going to also just move these 2 clicks to the end, and I'm going to add a few more 3 clicks in. Actually, while I've got this happening, you can select multiple clips by selecting one, holding down the Shift key, and clicking on another. And now that I've got these 2 selected, I'm going to right click and just say duplicate. Now it's actually chucked it right out at the end of that that channel, or that track, I guess. I want to drag it back to lock with those ones there. Okay, that's actually the way I want my sounds to play in this case. Let's give it a play and see if it works as we expect. So you'll notice that we're not actually getting the proper spatialization of that sound that's on the sphere. The reason for that is that our sphere audio source is still using the 2D spatial blend. So it's not paying attention to where in the scene that object is. All it's paying attention to is this volume and this stereo pan. So I'm going to slide this all the way over to the right. So now we're using the 3D spatial blend, and we'll give that another run. And now you can really hear that moving around within the space. Cool. So that's all the timeline stuff that I'm wanting to show you today. That was just obviously an introduction, and you can do more complicated things with timeline. If you're kind of doing super fancy stuff, you'll probably find yourself reaching quite quickly for some middleware, something like Wires or Fmod or something like that. If you're wanting to kind of get into that stuff, then Maze and Tigran did a workshop on it a couple of days ago, and I'll add a link to that workshop below the video. But the last thing I'm wanting to show you here in this tutorial is how to use script to trigger sounds. And what we're going to do is just have a couple of buttons that the user can press, and each of those buttons is going to play a different sound. So nice, simple, in response to some user interaction, let's make a sound happen. Now, Unity treats scripts just like any other component. So in order to create a new script, we're actually going to click on the Add Component button. Because I want to play the sound out of the audio source that's on the cube, I'm going to add this script onto our cube object. It could be anywhere, really, but it just, in this case, to me, it makes a bit more sense to have that, that component on the cube. So I'm going to click on Add Component, and we need to come up with a name for our script. In Unity, the names of scripts need to have no spaces in them, and they should start with a capital letter, and if they've got kind of multiple words, then every word should also start with a capital letter. So I'm going to call this beatbox. Well, now I need to decide whether beatbox is all one word or two words. I think beatbox is one word. Okay, so you see I've typed in beatbox in the search field here. Unity's sort of said, well, there's no component called beatbox, so maybe what you're trying to do is create a new script. And I say, thank you, Unity, that's exactly what I'm wanting to do. And it says, would you like that new script to be called beatbox? And I say, yes, indeed, I would. Create and add. And if you give it a minute, I'm not sure why that takes a minute, but you'll see that a new component has been added to our cube, and it's a script called beatbox. And if we double click on that, it should open up Visual Studio. If you are using a Mac, then it will probably open up MonoDevelop instead, I think. MonoDevelop's a good bit of software, but it doesn't have some of the fancy stuff that some of the sort of code hinting doesn't work quite as well as you'll see it here in Visual Studio. Okay, so this is what the default Unity script looks like. I won't go into too much detail, but I just want to talk a little bit about the general structure of it. Up here at the top are the libraries that we're bringing in. So in order to explain that, C#, the language, knows how to do some things. But C# is a generic language which is used for a bunch of different applications. It's not, Unity is not built into C#. So in order to get Unity to understand C#, in order to get C# to know about Unity, we need to say, hey, C#, use Unity Engine. So this line here says, hey, C#, go and find Unity Engine and learn all about Unity. And we also, by default, it's including a few things called collections and collections generic, which are things like lists and dictionaries, which if you've done some coding before, you might understand. If you haven't, don't worry about it. So this first bit here is just including some libraries to give some extra capabilities, I suppose, to C#. This bit here, public class beatbox mono behavior, says that we're defining a class called beatbox, and that's essentially what we're doing. We're creating a thing called beatbox, and it's a mono behavior. And the mono behavior in Unity is kind of just another term for a component. So this is saying we're creating, using this script, we want people to be able to create beatbox components. So all of that's auto-generated. You're not going to need to change any of that. Everything between this curly brace and this one here is kind of the meat of the script. It's what it really does. And by default, Unity, the default Unity script will include a couple of methods. And it's got some comments here that explain what each of those methods do. Now, any line that starts with a / is a comment. A double slash is a comment. And Unity will just essentially ignore all that. So if we want to write in something for us to read, not the computer, then we put a // before it. And this can help us sort of explain our code to another programmer or to our future selves. I'm going to delete that now. And so the comments that Unity has put in there has said start is called before the first frame update. So it's basically saying that this bit of code is going to happen at the start of the game before the very first frame even happens. And this comment here says update is called once per frame. So this bit of code is going to happen every single frame. Now, for the script that we're doing today, we're going to be mostly doing stuff in update. But I just want to show you something that if you haven't used C# before in Unity, this might be helpful to you. I'm just going to put a line in here beneath start and between the two curly brackets. I'm going to say debug.log, it's capital D, capital L, open bracket, open quotes, hello world, and then I'm going to make sure that there's a semicolon at the end. And what this is going to do is, because it's inside the start method here, it's going to be called before the first frame, and it's just going to print out to our debug console whatever is between those quotes. So it's going to say hello world on our debug console. So what you want to do is just save that file, Control S, then come back to Unity and hit play. Okay, now the game is playing. Down here in the tab next to project, you'll see console. And if we switch over to that, what you should see is hello world, which is the debug code that we logged out. Now, maybe you're not seeing hello world there. Maybe you're seeing an error. And what I'm going to do is I'm just going to create an error so that we can see what that looks like. By far the most common error that anybody is ever going to do in C# is they're going to forget to put that semicolon at the end of the line. So you'll see there that there's a little red underline, and if I hover over that, that Visual Studio is telling me that a semicolon is expected. But let's just ignore that for now. We're just going to save it and come back to Unity. And you'll see here that already we're not even running it because this is what's compiler error. There are sort of two types of errors. There's compiler errors, which happen when Unity tries to kind of build the game, and there's runtime errors, which happen when the game is running. This is a compiler error, so it's already happened even though we're not running the game. And I guess what I'm wanting to show you here is that an error message is quite descriptive, and if you just read the error message, it can sometimes tell you what the problem is, or it can always tell you like where the problem is. So what this is saying is that in the assets beatbox.cs file, which is our beatbox file obviously, on line 10 at character 33, so it tells us exactly where the problem is, we got this error code. Generally the error code isn't that helpful, but often the text which comes after the error code is. And it says here, semicolon is expected. So we go, all right, on line 10, I forgot to put in a semicolon. Something that I've found with a lot of students is that they tend to freak out a bit when they get an error. They go, oh no, the computer's telling me off. And sometimes as a response to that, they don't read the error message, and they kind of quickly go and start trying to fix their code without having properly read what the error message was. So I'm just saying, please, if you get an error message, just read and try and understand it before you come back and try and fix it. Okay, so with that said, we've got this line here that says hello world to the debug log. And that's really just to demonstrate that Unity is actually listening to us and doing something. Okay, what we're really wanting to do with script happens here in the update. And what we're going to say is basically if the user pressed a particular button between the last frame and now, then I want you to play a sound. Now, in C#, an if statement looks like this. We say if, and then in brackets we put a condition. I'm just going to type the word condition there for now. That's not valid code, that's why it's all red underlined. But this is kind of just the general form for how an if statement will look. So if this condition, if this thing is true, then do this stuff. And so, yeah, let's sort of go in and fill in these two things now. So the condition, what we're going to look at is has the user pressed a button since the last frame? And in Unity, we do that by saying if input dot. Now, there's a few different ways to do this. There's get key down. We could say, if the user has pressed the E key since the last frame, then play the sound. What we're going to do is something a bit different. We're going to say if get button down. If this button has been pressed down since the last frame. We could also say if get button up, if this button has been released since the last frame, or if get button, like if this button is currently down in this frame, then do this thing. What we're going to say is if get button down, and this bit of help text here is saying that it wants to have a button name in here. What I'm going to do is I'm just going to put fire1 in there. And I'm going to show you in a second why that's there. For now, we're just going to do another debug.log in here. And I'm going to say debug.log pow. So if the fire1 button has been pressed this frame, then say pow to the debug log. Let's give that a save and come back to Unity, and I want to show you where buttons are. So buttons are a way that Unity has of defining certain inputs from the user and tying them to a bit of code, like in this case the word fire1 is the name of that button. Now let's come up here to edit project settings down near the bottomish. And over in the left hand side here, you're going to want to look for the input manager. Now this is sort of in flux. Things are changing a bit, and there's an input system package which you can use instead. For now, we're just going to be using the input manager here. Now under axes, there's a bunch of different things here. And you'll see that there's actually two listings for fire1, which is the name of the button that I put in. And if we just open up each of these, they say this button's called fire1, and it's tied to the left control. It's also tied to mouse 0, which I believe is the left click. And there's some other kind of values for it here. And if we go and look down to the other fire1 definition, again it's called fire1, and it's attached to joystick button 0, which that'll depend on what sort of gamepad you're using or whatever. I believe that if you're using, say, an Xbox controller, that will be the A button. So you can see here that the input manager lets you sort of tie a button to a bunch of different kind of things depending on what input system the player is using, which can be really useful. It's not sort of perfect. Something that is really good for accessibility that this system doesn't let you do easily is allow the player to customize their own button layouts. But for the purpose of this game jam and for this tutorial, this is going to be enough for us, I think. So yeah, you can see that we've got a bunch of axes or buttons and things already defined. We're just going to use fire1 and fire2 which are the left control and the right control, or I think the left mouse and the right mouse. You can also define your own inputs here if you want, but we're just going to use those pre-existing ones, Fire 1 and Fire 2. So, left control is Fire 1. Let's close down this project settings and see if our bit of code is working. So hit the play button. Hello world has happened. Now if I press the left control, you'll see that power comes up here. If it hasn't, then you've done something wrong. Have a little rewind and see if you can get it fixed. Obviously we don't really want power to just come up in the console here. We want a sound to play. So in place of this, we're going to want to play a sound. Now before we can play a sound though, we need a reference to the audio source that we want to play the sound from. And in order to do that, we're going to come up here inside the curly braces for our beatbox class, but outside of the start method and the update method curly braces is where we kind of define our variables for this class. Now a variable is like a container that stores a value, and in this case we're going to create a container that stores a value that lets us know which audio source we're playing out of. Now in C#, the format, the general kind of form for defining a variable is that first of all we say its scope. I'll talk a bit about that in a second. We're going to say that this is a public variable. Then we say the data type. And in this case, as I said, we want to store an audio source in this variable. The data type is audio source with a capital A and a capital S. So we're saying public audio source, and the final part of this sort of line is that we need to give that audio source a name. In this case, it's the source. I want to store in here the source that's attached to that cube object. So I'm going to call this variable cube source. Notice here that a convention that I've used, you can pretty much use whatever capitalization you want. But in C#, the general convention that's suggested is that for variable names, the first letter is lowercase, and then every other word after that starts with an uppercase letter. Okay, so this is a variable called cube source. It's going to contain an object of type audio source, and it's going to be public. Now this public just means that this variable can be accessed not just from this script that we're writing, but from anywhere. And when I say anywhere, that includes from the editor here. So I've saved that, come back to the editor, and you'll see here now under our beatbox component that there is now a variable called cube source that we can put an audio source into. And our beatbox script is attached to our cube. So I actually want this audio source to be in there, and I just have to click and drag it, like so. And so now, if I come back to our script, now Unity knows that whenever I type cube source, I'm talking about this audio source that's attached to the cube. And so what this lets me do, I'm just going to delete that debug.log power. This lets me say cube source dot, and the dot means I want to do something to cube source. And you'll see that there's all sorts of suggestions for what I might want to do. I might, if I want to change the volume, I would say cube source dot volume equals whatever I want the new volume to be. In this case, what I'm wanting to do is to play a sound. Now I want to actually use this method here, play one shot. And this just gives us a description here. Plays an audio clip and scales the audio volume by the volume scale. Basically, it's just playing a sound once off. I say cube source.play one shot, I open a bracket, and inside those brackets, what Unity is expecting is an audio clip. Now, currently, I don't have a reference to that audio clip. So what I want to do is come back up here and create another variable. Just like I have an audio source variable, I'm going to create an audio clip variable in which to store the audio clip that I want to play when somebody presses the left control. So again, I'm going to make a public variable. I'm going to call this of type audio clip in this case, because we're going to store an audio clip in this variable, or a reference to an audio clip in this variable. And I'm going to call this fire1 clip. So down here, well, let's save that for a minute. No, sorry, we've got an error. So if we were to go back to Unity now with this error, because I haven't finished this line, we wouldn't get our new variable showing up because we've got a sort of an unresolved error. So what I'm going to do is come down here. I'm going to say inside this play one shot brackets, I'm going to say I want to play the fire1 clip. I said before that semicolons are the most common mistake that you're going to make, the most common error that you'll get. The second most common error is that you're going to have typos in your variable names. You're going to write fire1 clip up here, and then you're going to write fire1 clip down there, but you're going to have a lowercase c down there instead of an uppercase c. So just make sure when you're typing variable names that you type them exactly the same each time. Okay, so cubesource.play1shot in brackets fire1 clip semicolon to end the line. I'm going to save that and come back to Unity, and now we've got fire1 clip showing up here under Beatbox. If I come back to our project, come into our audio folder, oops, you'll see that that's vanished. Let's select cube again, and there it is again. I'm going to drag this pa sound audio clip onto our fire1 clip variable there. And once that's done, let's give it a play. So we get those sounds playing. Now if I press the left control button, I get the pass sound whenever I press it. So that seems to be working nicely. The last thing I'm going to do is basically that same thing again, but for my t sound here. So it's so similar that I'm actually just going to copy and paste these things. I'm going to create two new variables. No, I'm not, sorry. We're still going to play it through the cube source, but I'm going to create another audio clip variable, and I'm going to call that fire2 clip. And then down here, I'm going to copy and paste this whole if statement. But this time around, I'm saying if input.get button down fire2, so if they pressed the fire2 button, which if you recall was the left alt key, if they press that button, then we want to, still on the cube source, play the fire2 clip. So save that, come back to Unity. Now what we're going to do is drag this t sound onto the fire2 clip. I just want to show you what's going to happen if we forget to do that. So we do this, everything's running fine. I press the left alt button and nothing's happening. Oh, I actually thought I was going to get an error there. I'm not. Let me get an error intentionally by setting this cube source to none. Okay, so now it's not going to know what source to play the sound on. Let's give this another run. Okay, Now you'll see every time I press a character, I get this argument null exception. I wanted to show you this because I said a bit earlier there are compiler errors and runtime errors. This is an example of a runtime error. This is an error which doesn't get picked up before you run the game, but it happens as the game is playing. Okay, obviously to fix that, we just need to actually assign an audio source to this variable here. Last time I did that, I dragged the component onto that. What we can also do is just drag the whole object onto that. So I'm going to say drag this cube down there, and it works out that you want the audio source component from the cube. It knows that because it knows that it wants an audio source in this variable, because you said, hey, this variable, it's of audio source type. Okay, so finally we will drag the TUF sound onto our Fire 2 clip and give that a run. So now when we press the Fire 1 button, left control, we get pa, and when we press Fire 2, alt, left alt rather, we get TUF. And yeah, so already you're getting a little kind of musical instrument that the player can play around with. Hopefully you got all that working. If you didn't, then this Tuesday at 2 p.m, from 2 p.m. to 4 p.m, I'm having a bit of a drop-in session. You can come along with any problems that you've had here, and we can discuss them. Or if you if you got everything working fine, and you're just kind of wanting to discuss some next steps, then feel free to come along and we can chat about that as well. Now, if you're interested in the Godot game engine, then I'll be doing a really similar tutorial to this, just introducing you to the basics of the engine and how to get stuck in and play around with sounds in about a week's time. So check that out on the itch page if you're interested in getting involved in that. And finally, if that was all a bit basic for you and you're wanting to get into some actual procedural creation of sounds in Unity, then you might want to check out Chris Ratt's workshop on Saturday the 25th at 5 p.m. They're going to be taking you through how to use the programming language Chuck, the audio programming language Chuck, and Chunity or Tunity, I'm not sure how you say that, which is its integration into Unity. So yeah, that might be more interesting if this workshop was a little bit basic for you. Alright, thanks for coming along and giving it a go, and I look forward to seeing what you create in the jam. Today's tutorial is an intro to Godot for Unity people. No, it's not. It's not that. How to play a sound in response to an